I wanted to go over several application exercises that we didn't get to in class on Thursday. There are two of them at least are related one to another. This is a picture of Trinity Lake in California. This is where I grew up vacationing in the summer. You can see Mount Shasta there in the background, and the Trinity Alps, very beautiful part of California, surround the lake. Anyway, the basic externality problem that I wanted to do with you is this one. And what I'd like you to do is read over the problem carefully and then pause this screencast while the problem is still in view, and then hopefully you're sitting with a classmate or two. Try to solve the problem. Really push as hard as you can to solve the problem, and only then start the screencast back up. So I'll give you a few seconds to pause the screencast. All right, and now hopefully you've done your best to solve this problem. Maybe you took it home with no problem. That'd be great. Now if you've had that chance to do it on your own, now you're ready to see an explanation of how it's done. So here's how I would do it. I've transferred some of the information from this screen onto the next screen. Notice what we have here. I've taken the information about the demand curve. That's the marginal private value function, remember. I've taken the information about the supply curve. That's the marginal private cost curve. Then I've taken the information about that negative externality, $30 per motorboat rental. And then I've also just reminded us what we're looking for. We're looking for the difference between the market outcome, the unregulated market outcome, and the socially best outcome. What is that going to equal? Well, let's get started. Well, the way we're going to do this, we're first going to solve for Q naught, the market outcome. Then we're going to solve for the social best, and then we'll take the difference. Here goes. All right, well, we know that in the market outcome, we've got a supply and demand curve by assumption this market's competitive. Therefore, the private market solution is going to occur where quantity demanded and quantity supplied are equal. Remember, this is the private market outcome. And that means that this QD and this QS are the same, so I can just set the marginal private value and the marginal private cost equal to one another and solve for Q, since the Q in each equation is the same and those prices are the same. Those prices are going to be the market clearing price. So 300 minus 2Q, I'll just say Q now because I know QD and QS are going to be the same. That's going to equal 60 plus Q. And now I'm going to add 2Q to both sides and subtract 60 from both sides. And I end up with 3Q is equal to 240. And then that means Q naught is equal to 240 divided by 3, which is 80. So I'm halfway there. We'll just square that off so we know where to find it later. Now the socially best outcome is different in the presence of a negative externality. I'm running out of room. There we go. All right, well, here we know we're going to need our marginal social value function, but there's no positive externality, so marginal private value is also going to equal marginal social value, and that's because marginal external value equals 0. There's no positive externalities, in other words. Now, marginal social cost is another matter, right? There is an external cost, and we have to remind ourselves marginal social cost is equal to marginal, that's an M, let me fix that. Marginal private cost plus the marginal external cost. And we have all that information here. We're just going to plug that information over here. And so we end up with marginal social cost equals 60 plus Q. And then we're going to add that marginal external cost. That's 30. And we end up with marginal social cost equals 90 plus Q. And now our efficiency condition, remember that one, that's been the same efficiency condition as we've been using all along, but since we didn't have externalities in our model before, we couldn't really explore that efficiency condition adequately. But the efficiency condition is where marginal social cost equals marginal social value. So now it's a plug and chug problem, right? We determine that marginal social cost is equal to 90 plus Q. Marginal social value was equal to 300 minus 2Q. The quantities are going to coincide. Once again, quantity demanded, quantity supplied. We're going to be talking about the same quantity where efficiency prevails. So I've dropped those superscripts. And we end up with 3Q equals 270 once we subtract 90 and add 2Q. And I'm talking and writing at the same time. Obviously, when we subtract 90 from 300, we get 210. So Q star equals 210 divided by 3, that is 70. Square that off. And our answer, I'm going to put our answer in this last open space. Q naught minus Q star is equal to 80 minus 70 equals 10. And I'll stop this screencast here. I'm going to do one more related screencast, and that at the end of that one I'll graph this case. It's going to be the same case as this one as it happens.